Okay, so question 7. Triangles A and B are shown below. Triangles are placed together to form the larger triangle shown below. Is this triangle, this one here, is this right angled? So if we put this one with this one, is this right angled? Okay. First of all, let's annotate the triangle. So this would be 8. This would be 16 and 16. That'd be 22. And this would be 19. Okay, so the biggest angle on a triangle is always opposite the biggest side. Okay, so it's this angle in here we're effectively trying to work out, aren't we? We're trying to know, well, is that angle, is that 90 degrees or not, is effectively what the question is. Okay, 90 degrees, question mark. Okay, now if you think about what I've just said about the angle, a lot of folk don't quite appreciate that. If you imagine you've got a triangle like this, okay, very small angle, and you get a very small side. Obviously, as that opens up, that length gets bigger, that angle gets bigger. Okay, so the biggest length, the longest length is always opposite the biggest angle. Okay, and just think about that. Think about your arms. Put them in front of you and open your arms up. Okay, the wider you've got your arms open, the bigger the length between your hands. So that's why the longest length is always opposite the biggest angle. So you can kind of see it on this diagram anyway, but sometimes it can be a wee bit tighter than that. Okay, but yeah, it's that angle is that 90. Okay, so when we think about right angle triangles, I'm always thinking of Pythagoras. Okay, all this stuff jumps to my head. Right angles, hypotenuse, yeah, that jumps to my head. But we've got a triangle with 3 sides, and we're effectively trying to find an angle. So you could also do a cosine rule, couldn't you? You could say, well, cos x is equal to, oh, let's forget this, b squared, yeah, b squared plus c squared minus a squared over 2bc. You could do that and populate this, okay? Now, what's a, b, and c? No, actually, I've written x, so I shouldn't have written x. Cos a, okay? So if we said cos a, then this is a, and the side opposite would be small a, and then these would be b or c, wouldn't really matter which, okay? So we could do it that way. We could absolutely do it that way and substitute in. But I don't know if that's my first thought when I see these questions is more Pythagoras. But that's a valid way of doing it. And if you thought on that, I think that's quite I think that's kind of thinking out the box a little bit because I'd say your training when you think about proving if things are right angles is more Pythagoras. But that's a valid, you know, you've got a triangle, you've got 3 sides, you could do cosine. Okay. So yeah, I'm just going to stick to Pythagoras. Okay, so the first thing I do with this is your converse of Pythagoras theory. I always do left hand side and right hand side. Okay, what you cannot do is say at any point 8 squared plus 9 squared equals 22 squared. Right? You can't say that because we don't know that's true yet. We're trying to prove it. Okay, so don't write that. Okay, what we are going to do is do some 2 separate independent calculations and then put them together. Okay, so on the left hand side, well, first of all, if we're saying this is our angle, okay, what's the hypotenuse? So the hypotenuse is going to be 22. Okay, so on the left hand side, I'm going to say 8 squared plus 19 squared, and on the right hand side, I'm going to say 22 squared because we know that with Pythagoras, we should have a squared plus b squared is equal to c squared. Okay, that's what should happen. Okay, but we can't write that just now on the page because we're trying to prove that. Okay. So calculators out, 8 squared plus 19 squared. If you can do that in your heads, I'm very impressed. So 19 squared is 361, 8 squared is 64, so that's 425. Okay, and 22 squared is 484. So 425 does not equal, sorry, so maybe just say, we'll say that, okay. And then I think we want to have a separate line where we just talk through what we've worked out, okay. So I would say left hand side does not equal right hand side. 425 does not equal 484. And that's kind of how I'd be describing it. So therefore, and that's just the three little dots. Therefore, the triangle is not a right angled triangle. I'm just going to say RAT for short. Okay. Therefore, angle does not equal 90 degrees. Okay. Maybe we don't need that last line actually, but that's how I'll be laying this out. Okay. So looking at the marking strategy, you're going to get a mark for this and the other side. So a mark for doing your 8 squared, 19 squared, and 22 squared. You're going to get a mark for evaluating it. Okay, so you're going to get a mark for actually working the numbers out. And your final answer is comparison and conclusion. Okay, so left hand side is like right hand side. Yep, so these three lines here are going to be your final mark. So quite an easy 3 marks really. Cosine would have been just as easy a way to do it as well, I think. Working at the angle, say it's not 90. The point with this, like I said, the big thing is just don't go in saying a squared plus b squared is equal to c squared. Okay, keep these calculations separately. Okay, so calculate, evaluate, and then make your conclusion. Okay, so yeah, good question. That nice wee 3 marks in the bag. All right. Question 8. How much time we got? Loads of time. You will notice that it takes me longer than the allocated time to go through one of these papers. Probably not by a huge amount actually. It was about 12 minutes of video. Was it 2? Yeah, probably not a huge amount more. But it does show you that, you know, if you can spend the time to think, you don't have to rush, because actually I'm a bit over, but I'm really, really going off track sometimes, So there is plenty of time just to sit down and think. Don't be feeling that you should be just rushing through, and if you want to come back to questions, come back to them, Don't just rush through and then come back and then realize you've done anything wrong. Take your time to really get quality over quantity. Okay. This looks a bit more complicated for vectors. A bit more in this one. Still only 3 marks though. Okay, and the first one is just 1 mark, so it should be very straightforward, although it does look like there's a bit in it. So in the diagram below, the 2 vectors represent, RQ and PQ represent the vectors C and D. Okay, so we can see them up there. And again, they draw it out for you. They never draw it out for you. I think life is quite tricky, but they draw it out for you. Express PR in terms of C and D. Okay, so P to R. I'm going from P to R, right? Like that. So how do I get from P to R, knowing what I know about D and C? Well, I would go along D and I would go down C, wouldn't I? That's the way I'd go. Okay. So along D, just D. But C though, so C actually goes in the opposite direction to the direction I want it to go in. So if I want to go this way, I need to do negative C. Okay? D, negative C. Okay? But dead straightforward with the vectors, we're just adding them head to toe. I want to get from P, and I want to go to R. So I'm going along D, and I'm going negative C. Okay? It's really as simple as that. Good stuff. The next part, okay? So TP is equal to PQ. So what I do here is I start labeling up my diagram. TP is equal to PQ. So that to me means that equals D. Okay. TP, PQ, they're both the same length, they're both the same vector. Okay. V is the midpoint of PR. So all that means is it's halfway down. Okay, so let's remember, well, we can see that, so I'm just going to scroll that out. I like to just know I've acknowledged information and get rid of it. Okay. Express TV in terms of C and D. So we want to go from T, we want to get to V. And the only vectors we know are C and D. Okay, well let's have a think. Let's try and draw it through. I'll maybe get the I'll get the highlighter out. Well, I'll get the highlighter out. I'll use I'll use that. Oh no, it's too big. The highlighter's too big. I'll use the orange pen. Orange pen. So basically, we're trying to find this vector here. Okay, but we don't know this vector. So what vectors do we know? Let's think. I'll go for pink this time. Go pink. So we know this one is D. And so right away we're thinking, okay, I can go along D. And then I want to go down here. I don't know, I want to go down this way, but I don't know that vector. Okay. What I do know is that that is equal to half PR. Yeah. I don't know what PR is. I know that PR is D minus C. So I'd be saying D plus a half brackets D minus C. Okay, now if you never spotted that, is there another way of doing it? Let's have a think. We could have gone the other way, I suppose. We could have said, well, let's go along D and then along this D. So we could have said, I'm just going to put this at the side because this isn't really the best way of doing it, but you could have said, I'm going along D, then along another D, and then I'm going to go down C, and then I'm going to go halfway up R to P. Okay, so plus half R to P. Okay, so you could have gone that way. Now, if PR is D minus C, R to P is C minus D. So that then is equal to C minus D. So we could have said, let's see, we could have said D plus D minus C plus a half of C minus D. Okay, that's if we go the long way. Okay, and that would have given us the same thing. So I was just checking to see if there was maybe another way that way that would have looked simpler, but it doesn't really look like there is. Okay, so yeah, I wouldn't really suggest going that way, but you know, just to make you think about what the just to talk around the question, all right, help burn that time. So yeah, D plus a half DC. So what does that mean? So we have D plus a half D minus a half C. So let's group them together. D and a half D. That's obviously going to give us 3 halves D. Yeah, because this is effectively 2 halves, isn't it? Okay, minus a half C. And then we could take out the half as a common factor. Yeah, and say, well, that's going to be 3D minus C. Okay, so that's quite a wee bit of working, I think, for 2 marks, but let's just check what the marking scheme says. Got 2 minutes to go. Okay, so the first one you're getting your mark for D minus C. So that's fine, 1 mark in the bag. And then, so I'm going to go to a red pen, I'm still on purple pen. And the second one, now the way they've written it in the marking scheme is they want you to write down the letters, you know, the T to P plus P, you know, etc., like that, which I've not done. So I'm just going to check to see if that is a problem. I don't think that's a valid problem. I think that's okay. Effectively, they want you to write as a first step TP plus a half PR, just as a first line, okay? Which then obviously becomes D plus. So I think you'd be okay. But you're going to mark for your pathway and then a path for the simplified expression. They've actually just left it at this point, so they don't even want you to take out the common factor. So yeah, to do that's fine. But actually, if you'd left it at this stage, that was okay. So yeah, you know what? Just to be fair, maybe write this to begin with in letter form, and then go into the vectors. But I think having this as your first line isn't a problem. So yeah, I hope that's been helpful chatting about vectors.